The wave speed, yesterday we did about the wave equation. That's wave speed or speed of a wave is frequency times the wavelength. Frequency refers to how many vibration or how many waves completed in 1 second. Wavelength is refers to length of a one wave. The SI unit is meters. And what are the wave fronts? Wave fronts are actually the points which are representing the identical points of different waves. So example, say we have a source and which is emitting out multiple waves. So this is wave A, this is wave B, and this is wave C. So multiple waves are emitted out from the source. So this is a source. So when we mark the identical points of waves, like examples, I mark crest here, crest and crest. And when I join the identical points of the different waves, the line which represent like what we did, we have multiple waves are there, like we have many waves are there, and we join the identical points of different waves. The line which is joining the identical points of the different wave, what we call that line? We call that as a wave front. Means phase of front of the wave. So same way, and it is always identical. It's not like crest and trough. If I mention crest, so I should mark another crest of the different waves. And when I join them by a line, what I will call this line? I will call that as a wave front. Same way, and what is the difference? What is the distance between the two successive wave fronts? That is equals to wavelength. Why it is a wavelength? Because the distance between the two in phase points, that is always equals to 360 degrees or 2 pi radian, or in terms of the length, that will be equals to wave length. So when we join the identical points of the different waves by a line, that line is known as the wavefront. Is it clear, the concept of the wavefront? And the wavefronts can be spherical. The wavefronts can be spherical, it can be circular, like as you can see here, this is a spherical wavefront. How we know the wavefront should be a spherical or the wavefront should be a circular or the curve? If all the waves are traveling in same direction. We have waves and they all travel in the same direction. So what kind of, how we represent that wave, which is all the waves are going in the same direction. So we represent by a plane wavefront or a straight wavefront. And the direction of the wave is perpendicular to the wavefronts. But if waves are traveling in different directions, like one group of wave is moving towards right, one is moving towards left, one is going up, one is going down. So waves are traveling in all the directions. How we represent these type? So when we join the identical points, so what we get a circle. So in that case, the identical points, when you join, we get a spherical wavefront. So wavefronts can be spherical, it can be a plane. How you know it's a plane wavefront? It means all the waves are going in the same direction. How you know it should be a spherical wavefront? If waves are traveling in all the direction, then it should be a spherical. It can be a curve as well, which is also a part of spherical. Example, if one group of waves are moving in this way, then how I represent this type of wavefront? I'll represent this type of wavefront by curve. Is it clear, the concept of the wavefront? So how we can draw the wavefronts here? Like if you want to draw the wavefronts, so there is a principle which is known as the Huygens principle. So if we want, what is the Huygens principle? Huygens principle is like if you want to locate the position of the new wavefront from the wavefront which we have. Like example, say this is given to you, this wavefront is given to you, and the question is sketch means find the position of a new wavefront when the wavelength of a wave which you are using is 3 centimeter. So what we do in the Huygens principle, we use a compass and we place the compass, the needle of the compass, and open the compass up to the length. Like example, if a wavelength is 3 centimeter, I'll open 3 centimeter. If wavelength is 2 centimeter, I will open 2 centimeter. Like, let's take wavelength is 5 centimeter. So instead of 3, we have 5 centimeter. Now, what we will do, we'll draw an arc. So we place on the given wavefront, we place it on the given wavefront, and we will draw an arc. Then we move the compass to new position, anywhere you can move, and draw another arc. Then you move the compass to new position, and draw another arc. Then you place the compass to new position and draw another arc. Now the position or the point where these arcs will intersect, like we place at different positions. So the point or the position where these arcs will intersect, what we do? We draw a straight line. We draw a line. We join those points. So this is a point where the arcs intersect. This is a point where arc intersect, and this is a point where arc intersect. So I will draw a line. I will join those points, and I will draw a line. So means this is a new position of the wavefront, and the wavelength is equals to 5 centimeter. So this is known as the Huygens principle. So using the Huygens principle, how we work out the new position of the wavefront? We mark, like the given wavefront will be there, and we mark a point on the given wavefront and draw the arcs at different positions. The point where the arcs intersect, we join those points and we get the new position of the wavefront. This is known as the Huygens principle to work out the position of the wavefronts. What if we were having a curve? Like example, so it was not a straight, it was now if I set like example, I change here, I have changed the length. It was the length which I open. This was 5. So that's why I said it is 5 centimeter. But what if it was a curve? Like example, the wavefronts were curved and you want to find the new position. And the wavelength is example 5 centimeter again. So you will place the compass. You will place the compass and draw an arc. Then you move the compass to new position. Draw another arc. Then you move the compass to new position. Draw another arc. So different position, we place the compass and we do the arcs. And then what we do, we mark the points where these arcs intersect. This was a point where the arc intersect. This is a point where the arc intersect. This is a point where the arc intersect. So I will join these points by a line. When I join these points by a line, what I will get? I will get the new position of the wavefront. And the spacing between the wavefronts should be equals to the wavelength. Is it clear? The concept how to work out the new position of the wavefront using the Huygens principle? Any question or doubt in this? No, you can directly draw. This is just a this is just a manner to show the wavefront. Like example, this is just a way the Huygens principle to locate the position of the wavefronts. If you want to locate a new position of a wavefront, we use this principle. So what? So even for example, say you have a straight line, and the question is the wavelength is given, like let's say the wavelength is given 5 centimeter. So if it's a straight line, definitely next will be the plane wavefront. So the position of the next wavefront will be 5 centimeter from this one. And so you just measure the distance between the two wavefronts, like the new position 5 centimeter, you got the position. That's right. But this is the Huygens principle of locating a new position or the position of a secondary wavefront. So what he did, according to his principle, he marked point on the given wavefront and draw an arc. Then take another point, draw an arc. Take another point, draw an arc. And the position even you can work out, locate the position. Like example, if you join these points also, if you work out intersection of arc, that is also fine. If you just work out these points like identical and you join them by a line, you will also get the same result. So if I draw, like identify these points and mark and draw a straight line through those identical points, that will also give us the position of a secondary wavefront. So both ways give the same result. The Huygens principle, mainly he used this method, like taking the maximum position from the point so same way, like example, if it was a curvature, if it is a curvature, we drew an arc, then we drew an arc, then we drew an arc. So this is a point, you mark these points, and if you join these points, you will also get the same result. So this blue line is representing the new position of the wavefront. Is it clear? The Huygens principle? In exam, they don't ask the Huygens principle, but this is part of the syllabus. Like you should know that what is the Huygens principle to locate the position of a secondary wavefront. Normally, we just directly draw the wavefront instead of considering the Huygens principle because it takes time as well. Then these are some definitions which you have to learn about the wavefront. What is a wavefront? The line that join the particles of same phase, like either all the crest or all the trough, that's called the wavefront. When we say in phase, if one wave appear to with a crest and the other appear trough in the same, like the points which have no phase difference, like 0 phase difference or 360, we call in phase. And the points which are vibrating in opposite manner or 180 out of phase, 180 degree phase difference, we call them as out of phase. Or Antiphase is the right term. Then the coherence. What is the meaning of term coherence? The source with a wave are like example, which are having a same wavelength, same frequency, and two waves exactly in phase at all the points. We call them as a coherence. Like, for example, if we have this is a source, this is one wave coming out from the source, and this is another wave coming out from the source. So when two waves or two or more waves are coming out from the source and they have the same phase difference, like zero phase difference between them, and they have the same wavelength, they're starting in the same manner. So what we call these type of sources, we call that as a coherent source. Like they have a constant phase relation. But what if, say, one of the wave starting in this manner and the other wave from the source starting in this manner? They have the same wavelength. So we cannot say it is a coherence. Why we cannot say it's a coherence? Because one wave completed crest and trough, other one is just starting with the trough. So these waves are not coherence. Or coherence is actually the term used for the source. We say a coherent source or a source is not coherence. The best example of the coherent source is a laser light. The laser light white appear to be very high in intensity because all the waves are vibrating in the same manner when it is coming out from the source. That's why the intensity of the laser light is much higher as compared to intensity of a filament bulb or a filament lamp. Because in a filament, the filament bulb is not a coherent source because what happened? Some waves are starting from here, some waves are starting from here, some waves are starting from here. So when they're coming out from the source, they don't have a constant phase relation. Like they're not vibrating in the same manner. That's why the filament bulb is a non-coherence. But in a laser, all the waves are produced from a same single point. That's why we call laser lights are the best example of the coherent source. So coherence is actually a term which is normally used for the source rather than for waves. Is it clear, the concept of coherence? Any doubt till this point? About the phase difference and the part difference, we will have this in the property of a interference. So there we'll discuss in detail. The phase difference should be zero in coherence. That's right. This is just an example. The diagram below shows a transverse wave. Before this example, there's one more point, which is about the intensity of the wave, and then we'll move on to the intensity of a wave. How we define the term intensity of a wave? Intensity, it is energy on unit area in 1 second perpendicular to the surface on unit area. So how much energy is coming from the source in 1 second, which is perpendicular to the surface? We call that as intensity of the wave. Example, say this is a surface and this is a wave which is carrying energy. Say 30 joules of energy is there. On say 1 meter square area in 1 second. So what is the concept of intensity? The intensity of a wave means how much energy is received by the surface or how much energy is carried by the wave which is perpendicular to the surface, 90 degree to the surface. As you can see, this angle, like the direction of the wave and the surface, is 90 degree. So how much energy is received on the surface in 1 second on a unit area which is perpendicular to the wave, direction of the wave, that we call intensity. So if I write here, look, so means intensity is energy on a unit area in 1 second. So intensity is energy divided by area divided by time. So what is energy divided by time? What is energy divided by time? What we call energy in a unit time. We call that as a power. So means intensity is actually power acting on unit area. But the one condition that the wave should be perpendicular. Like if it is not perpendicular, then we'll take the component of the energy. Even though energy is a scalar quantity, but intensity, the term intensity is like the part of the wave which is perpendicular. So intensity, whenever we need the intensity of a wave, it is power acting on unit area. So if I say, so what is the intensity of this wave? So intensity will be equals to the energy. What is the of power in unit area? So 30 joules in 1 second. So what is the power here? It's 30 watts. And what is the area here? It's 1 meter square. So what is the intensity? Intensity is 30 watt per meter square. So intensity of the wave, in this case, it is 30 watts per meter square. And intensity of the wave is directly proportional to amplitude of the wave square. Means if we double the amplitude, the intensity will be 4 times. If we triple the amplitude, intensity will be 9 times. If we quadruple the amplitude, the intensity will be 16 times. So if the amplitude of the wave is double, the intensity will increase by factor 4. If intensity of a wave is 3 times, amplitude is 3 times, intensity will increase by 9. So if we have two waves coming on the unit surface, one is having an amplitude of 2 meters, another one is having the same amplitude is there 4 meters. If I compare and on the same unit area, same time, if I compare the intensity of wave A with the intensity of wave B, so what will be the comparison? Because intensity is proportional to amplitude square. So here amplitude is double. So if an amplitude is double, what will happen to intensity? So intensity of a B will be 4 times as compared to intensity of A. Like if intensity of A was I, then intensity of B will be 4I, 4 times. Is it clear till now, the concept of intensity? Why 4 times? Because intensity is directly proportional to amplitude square. Means here the amplitude was 2 and here amplitude is 4. So how many times the amplitude has increased? So amplitude increases by 2. So if the amplitude has increases by 2, if one is having a twice amplitude than other, so what will happen to intensity? It will increase with the square. So it will become 4 times. So it's a comparison. So if you compare amplitude of a 4, like B was having amplitude of 4 and A is having amplitude of 2. So because the amplitude of A compared to B, B is twice of A. So if the amplitude is twice, what will happen to intensity? Intensity will be 4 times. Or there's also another formula you can derive from this relation. Intensity divided by amplitude, because when two quantities are directly proportional, their ratio will be constant. So what is the formula? Like if we want to compare the two waves, say wave 1 is there, intensity A, and wave B is there, intensity B, and they have different amplitudes. Say the amplitude of A is A1, amplitude is A2. So the ratio between, because if two quantities are directly proportional, the ratio will be constant. So I can say intensity of the intensity of the first wave divided by amplitude square will be constant. And here also intensity of the second wave divided by the amplitude of the wave will be constant. So when we compare, so intensity of A divided by amplitude of A square is equals to intensity of B divided by amplitude of B square. So this is also a formula which we can use to compare the amplitude and the intensities. Even you can substitute this directly in the formula, you will get the same answer. Is it clear, this relation about the amplitude and intensity? Any doubt in this? Then sometime we need the intensity, because the intensity of a wave, as a wave travel from one place to another, the intensity of the wave changes. Like example, if a person is there at position A and he is calling a person at position B, and another person is there at position C. So these two people will not receive the same intensity of the sound. As the wave progress, as the wave move from one place to another, the intensity will decrease. And what is the relation between the distance and the intensity? So the distance and the intensity of a wave is inversely proportional to distance square. This is called inverse square. What does it mean? Inverse square means, because it is obvious. Like if you are closer to the source, say you are playing any music and you're standing next to the speaker. As a result, what will happen? You will hear a louder sound as compared to if you are standing far from the source. So what actually happened? The intensity of a wave decreases as it progresses. It moves from one place to another. If the amplitude changes, like example, for light waves, what happened? The amplitude of the waves is usually, if it changes, then intensity will also decrease. Same thing for a sound. When we produce a sound wave, so what is actually happen? Like a person at position A, when he produces sound, the amplitude is also decreasing. So amplitude is decreasing, so it means the intensity will also decrease. So if you don't know the amplitude, there's also another comparison. You can also compare in terms of distance. What is the relation between the intensity and the distance, and specifically for the sound, that it is inversely proportional to distance square. So it means if we double the distance, if the distance is double, what will happen to intensity? It will decrease by 4. If the distance is 3 times, what will happen to intensity? It will decrease by 9. Because this is an inverse square. There, with amplitude, it is proportional. So when the amplitude was double, the intensity was 4 times, increasing. But here with the distance, if the distance is double, the amplitude will decrease by 4. If a distance is 3 times, the amplitude will decrease by 9. So if I say that this distance, say it was 2 meters, and this distance example was 6 meters. And if I say the intensity of A was I, what is the intensity of C? So how we know the intensity? You have to compare the distance. 2 meter becomes 6 meters. So how many times the distance has increased? By what factor? 2 become 3. So means how many times it has increased the distance? It has increased by 3. If a distance is increased by 3, what should happen to intensity? It should decrease by 9. So intensity will be I by 9 here. Like if this B experience receive the intensity I, this will be I by 9. Is it clear? This one? The relation between the distance and the intensity of the wave? Any doubt in this? So intensity increases with an amplitude. If I'm shouting, I will produce a high intensity wave as compared to a normal conversation. Same thing, if a person is standing closer to me, he will hear a loud sound or he will receive a high intensity as compared to a person who's far from me. Any question or doubt till this point about intensity? So example, if there is a lamp or a bulb which is say 60 watt, a 60-watt bulb is there or a 60-watt lamp is there, and I want to find what is the intensity at a point which is 2 meters from the bulb. So intensity at point A. So to work out the intensity, what is the formula to calculate the intensity? Intensity is power on unit area. We have the power, but intensity, whenever it is calculated, it is always calculated for area, not for a point, specific point. So means there will be so many points which will be 2 meters apart from A, apart from the bulb. All these points will be 2 meters apart from this bulb or a lamp. So means what it will make when I join all these points which are 2 meters apart, what it will make a sphere. So when I substitute the values, when I substitute the area, I will substitute the area of the sphere. So when I write here, intensity will be power divided by area, and area of a sphere is what? It is 4 pi r square. Why I'm writing d? D does not mean diameter. D is a distance here, which is a radius. If you're confused with d, I can also write r. It does not make difference. So area of a sphere will be pi r square. So means I have the power of this lamp. So power will be equals to 60, which will be 4 pi is 3.14. And the distance from the source is 2 meters, which is also a radius here. So I'll substitute 2 meter, 2 square. And that will give us the intensity of this point. Because intensity at that point A will be same as intensity of point B, intensity of point C, intensity of point D, and so on. Because intensity is not calculated at a specific point. Intensity means how much energy is coming on unit area in 1 second. So it is always calculated for area. That's why we substituted 4 pi r square. It is a sphere, not a circle. It will make a 3D structure. Like, because there will be a point down, up, right, left, in and out. So it was making a 3D structure. That's why I took pi r square, not a circle. Because try to imagine a 3D structure rather than a 2D. If it was in a 2D, then I'll take pi r, but it's a 3D. Like some of the radiation are into the screen, some of the radiations are out of the screen, some are towards left, some are towards right. So as a result, it will not make a circle, it will make a sphere. Is it clear? Yeah, so the area of the sphere is 4 pi r square. So whenever we want to calculate the intensity, intensity is always calculated for area, not the point. Say this is a lamp or a bulb, which is 100 watt. And we want to calculate the intensity at point A, which is 7 meter. Or say there's a bulb on the ceiling and I want to calculate the intensity, like we place a bulb or lamp on the ceiling and the distance of the lamp to the ground is example 12 meters. The power of this bulb is 30 watts. I want to calculate what is the intensity of the light on the floor. So when I want to calculate intensity of light on the floor, it means like there will be lot of points which are 12 meter apart from this bulb. So means when I join all those points, it will always make a sphere. So if I need the intensity, intensity is power on a unit area. So I substitute intensity, power of the bulb, the source 30, and area I will use 4 pi r square, where r is a distance. So what is the r here? It is 12. So intensity will be equals to 30 divided by 4 into 3.14 into radius, which is 12 square. And that will give us the intensity of the light which we receive. That is why, like example, the position of the light is also changes the intensity. Like example, when we place the light on the ceiling, means on the roof or the ceiling, as compared to the same bulb if I place here. So one bulb we place on the ceiling and another bulb is placed here. So which one, and if we want the intensity, find the intensity on the same point. So the bulb which is closer to that point will have a high intensity. So the position of the lights changes the intensity of the light which we receive. Is it clear, Isman? Any question or doubt till this point about the concept of intensity?